Hi everybody, it's Mrs. Burrows. Welcome to math this morning. I miss all of you guys. I am wearing my mask just in case I need to go outside, so I'm being safe. I hope you guys are being safe too. I would like to look at our math today. Before we start, we're going to be taking a look here at math on Monday, May 11th. I'm going to be looking at lesson 20.5, problem solving, making a model on pages 416, 417. Later on, Mrs. Duncan is going to come along and go ahead and review chapter 20 review test with you on page 419. So we're only going to be looking at lesson 20.5 right now. Before we start, I kind of want to give you guys a heads up. When we start today, you're going to need some things. You are going to need your pencil, obviously. I would like you to have a clean sheet of paper handy to work. And last but not least, you are going to need your math book. Open to page 416, 417. Now, when we are doing this today, a little heads up. I have the stuff I need to use for the math lesson today. You guys don't. So this is going to be a little tricky. I'm going to be showing you a lot of stuff up here on my Elmo that you guys aren't going to have at home. For instance, like my pattern blocks. That's okay. Some of the work that we are going to do in our book, we are not going to write on our page because I have no way for you to trace the shapes that you need. We'll just work on it together and we'll watch together. Some of the work you will be writing on your paper. So just keep up with me. And again, if you have any questions about anything, get a hold of me, get a hold of Mrs. Duncan, get a hold of Miss Comers, okay? Let's get started. First things first, I want to take a look at all these different shapes we're going to be taking a look at today. These are pattern blocks, and I bet you guys are recognizing some of these shapes. I'm going to go over here and for just a second, talk to you about some of these shapes. We have, to start off with, I see a hexagon, a five-sided or six-sided shape. I see we have a square that has four right angles. This is also a polygon because it's closed with straight sides. This is a polygon closed with straight sides. I see we also have a rhombus, which is similar to the square in that it has four equal sides, but it's different because it has two obtuse angles and two acute angles, whereas the triangle has four right angles. I also see some triangles. This particular triangle seems to be an equilateral triangle. I'm going to name it with its three names. Starting off with the angles, it is acute, so this is an acute, and I notice that it has all acute angles, and I notice the sides, the second name, they're all the same length, so it's equilateral. So this triangle is an acute equilateral triangle. I also notice that we have one of these guys, this red shape, which is something we call a trapezoid. I notice it is also a polygon. It has closed sides, but it only has two sets of parallel lines. So this is a trapezoid. The other interesting little shape I found over here was another type of rhombus. Definitely a rhombus with equal sides, but check out the obtuse angle on this one. It's much bigger than the blue one. Okay, now that we have all these shapes, I'm going to go ahead and pull up our book, and let's take a look at the page we're going to be studying today. Okay, let's look at this here. Get this out of the way. And on page 416, let's check it out here. Here's our page. Okay. Now, I know you guys are not able to write in your book. Please don't do that. So, you'll just have to deal with me. Let's take a look here. Problem-solving strategy now. I know in my classroom, I tell my kids about something called quips. Now, you might not do this in your classroom, but that's okay. I'm going to go ahead and talk about it so I know my kids know, and you guys will have something else to think here, maybe help you out. Quips is what I tell my kids to do when they have a word problem. And it stands for this. Q stands for question. Find your question. What is it you're supposed to find out? U means understand. You understand what they're asking you to find. I, what's the information they give you in the problem to help you? P, what kind of problem do you have? Are you going to be adding, subtracting, multiplying, dividing? Are you going to need to make a table? Do you need to make a model? Do you need to draw a picture? What is it you're going to need to do to solve your problem? And last, solve your problem. Today, we're going to be using a lot of the make a model part of solving our problem, and I'll show you what I mean in a little bit. I'm going to start by going to this word problem right here and finding our question. While I'm reading it, see if you can figure out what the question is. Okay, it says, Tina combined pattern blocks to make one large polygon. She used 3 trapezoids and 7 triangles to make her hexagon at the right. I'm assuming that this is the hexagon. Here it is, Tina's hexagon. What is another combination of pattern blocks that can be used to make a hexagon that is congruent to this one? Okay, did you guys find the question? It's a big one. Now I notice right away there is a question mark, and I'm going to look here. Yep, what is another combination of pattern blocks that can be used to make a hexagon that is congruent to this one? Okay, now let me see. I found my question. Now I need to go to the U. Understand. Let me understand what they're saying here. Another combination of pattern blocks. So do you remember all those different pattern blocks I just showed you over there? They want us to use different kinds of blocks to build the same shape. And I believe I'm right when I say same, because they want us to make a hexagon again. Hexagon has 6 sides. This has 1, 2, 3, 4, 5, 6 sides. And congruent to this one. So let me make sure I understand. Congruent. When we talked earlier, you may have listened to my discussion about congruent shapes that are the same size, same shape. You might have watched Miss Comer's link to the Brain Pop video about congruent shapes. So we're looking for a shape that is congruent or the same size, same shape as this one, but they want us to use another combination of blocks, so a different set of blocks. Okay, now this is the part where you're not going to be able to write this down on your paper, but I do want you to be watching what I'm building over there. Okay, let's give this a try here. I'm going to back out and go to my Elmo and see. All right, and the first thing I'm going to do is build Tina's shape and make sure that I have the same shape. Now, if I remember correctly, it said in the problem, she used 3 red trapezoids and 7 triangles. Okay, so let's start. Here is my first trapezoid, and then it looks like under that she put 3 triangles. So 1, 2, 3. Okay, and then under that again, she used some more some more trapezoids to get her shape here. And then it looks like, if you guys are watching in your book, you can see if I'm getting this right. Okay, there's that, another triangle, and she finished off her shape at the bottom with 3 triangles. And I'm going to check in my book, make sure that's the same shape that she built. Okay, that looks pretty close. Okay, here is Tina's shape. Now, what they want us to do is see if I can choose from all these other polygons. Is there another way I could build this shape using some different pattern blocks, different polygons? Now, to start off, I want to use one of these guys and see if I can get it to fit. Okay, I'm going to start right over here, building it there. Okay, I'm going to start there. Now let me think about this. I might use a rhombus here and a rhombus here. Let's see if I can still do that. Okay. I think I'm going to use one of these trapezoids again. And then down at the bottom, I'm going to use a rhombus and then a single triangle. Now, what do you guys think? Does that look pretty much the same? Do you think those are congruent? Think in your head. I'd like you guys to tell me how could I check for sure that these are congruent? What could I do? If you guys said, put this shape, overlap this shape, and see if it matches, you're right. Let's see if it matches. Okay, let's look. I'm going to start with my big hexagon up here. Set it on Tina's shape. Okay, I'm going to take my rhombuses, my other trapezoid, I'm going to take my other rhombus and that last, there we go. So what do you guys think? Did we make a congruent shape? We sure did. Okay, now I'm going to go ahead and go back to the pages. We've checked to see that it matches. I am going to go on to the next page, which happens to be 417, and see what our new example is going to be. Okay, now again, this is going to be a part of our lesson that you guys aren't going to be able to write on your paper. I would like you to watch and pay attention to what we're doing here. Again, they give us a question, so we need to go back and look at our quips and see what we can do here. Okay, make a model to solve. We're going to have to build another model here. What if Tina used, before I read, while I'm reading, I want you guys to see if you can come up with the question we're going to be needing to answer. See if you can find the question. What if Tina used pattern blocks to make the rhombus shown at the right? What is another combination of pattern blocks that can be used to make a rhombus that is congruent to this one? I saw 2 question marks. Use pattern blocks. What if she did that? I don't think that's what they're asking us to do. But let's check down here. What is another combination? I think this is going to be our question, and it's a long one. Whoa, that didn't work. Okay, sorry about that, guys. What is another combination of pattern blocks that can be used to make a rhombus that is congruent to this one? Okay, let's tackle this. There's my question. They want us to build another rhombus that's congruent. Now, let me understand. They want us to use another combination of pattern blocks, so a different one. I understand they want a different one to make a rhombus. So we know we need to make another rhombus, and it has to be congruent. Make sure we understand. So congruent, same size, same shape, different pattern blocks. Now, the information, they want another rhombus, and it has to be congruent. So let's go ahead and solve this. Now, they said, for our problem, we need to make a model. I'm going to go ahead and back out of this and build a model over there. And like I said, this isn't something you're going to need to write on your paper. This is something we're just going to look at together on the Elmo. Okay, let me get over there and build Tina's new shape and see what she has here. Looks like she used 2 trapezoids for this one. 2 trapezoids and 2 triangles. Okay, let's see. First trapezoid, second trapezoid, whoops, got an extra rhombus in there, and then it looks like she used 2 triangles to get this rhombus. Okay, now think about all of those other pattern block shapes that we have. Do you think there is another way I could make this shape using some different pattern blocks? Well, I'm going to see if I can use this big hexagon again. Oh, it's not going to fit up there. Oh, wait, maybe. Oh, look at that. It'll fit right in the middle. And I bet you guys can just automatically see what kind of shapes I could use to make a congruent shape. Now, this time, when I made my shape, I put it right on top of the other shape to see instantly that it is congruent. Now, this is a congruent shape that matches the other one. Do you think that we could use some different shapes to make another one? Let's build on top of that and see if we can build another one. I think this time I'm going to choose some of the blue rhombuses. Okay, that'll fit right there. Oh, I see another place to put a rhombus. Whoops, stay in there. Okay, and I'm going to get one more rhombus and see if it'll fit. Oh, went right in there. What do you guys think? Can I fill it up with another rhombus? I could also have used 2 triangles for that, or any combination of triangles. Okay, that was pretty easy. We just built 2 other congruent shapes that match Tina's original one. Okay, now we're going to go ahead and move on to the rest of our page. We just did number 2 as well. Use a different combination of pattern blocks to make another congruent rhombus. We just tried another one. So we've made some different shapes, different congruent shapes with those. Now, this time, on numbers 3 and 4, we're going to have to kind of work together on this. And I'm going to go ahead and go over to my paper here, and I'm going to actually label my paper. and put my name at the top so I know whose it is. And I believe we are now on page 417. So let me get that off there and make sure we have the right page number. 417. And we're going to be starting with problem number 3. Okay. Let me go ahead and get on problem number 3, and let's look at it over here first. I'm going to pull it up. This is going to be kind of tricky because I'm going to be switching back and forth to my Elmo and our paper, so let's take a look at that. First, question number 3, let's look at it. For 3 and 4, use pattern blocks to solve. Okay, I've got my assortment over there. How many green triangles are needed to make a figure that is congruent to a red trapezoid? Okay, I found my question already. Congruent, how many green triangles are needed to make a figure that is congruent to a red trapezoid? Now let me make sure I understand. We want to know how many green triangles are needed to make a figure congruent to the trapezoid. Okay, let me go over there and let's see what we can find out. So I've got number 3 written on my paper already. Now let's see what we can figure out here. All right, and I think you guys will be able to see this right away. Okay, there's my trapezoid, my red trapezoid. And I'm going to set it just like this. How many triangles do you think I'm going to need to build this thing? Let's figure it out. There's 1, 2. You guys said 3. You were exactly right. So for number 3, let's look at our answer choices here. For number 3, you guys are probably already there before I am, which is fine too. So number 3 took 3. So for number 3, our answer is going to be the letter B and 3. Took 3 of those. Okay, let's try number 4. How many red trapezoids are needed to make a figure that is congruent to the yellow hexagon? Okay, so I'm going to go through here. How many red trapezoids needed to make a figure that is congruent to a yellow hexagon? Let me make sure I understand. How many red trapezoids are we going to need to make a congruent shape to the yellow hexagon? Okay, you've got your paper labeled up for number 4 already, and our choices. F is 2, G is 3, H is 4, J is 5. Let's see what we're going to have here. How many of those am I going to need? Okay, let's look. Trapezoids. So we need red trapezoids. All right, here are some red trapezoids. How many red trapezoids am I going to need to fill up this yellow hexagon? Think about it. I bet you guys already can see that. I'm going to put 1 here, put another 1 here. How many did I need, guys? And I could have done that either way. I also could have done it this way. Okay, so if you said 2, you were correct. Okay, let's try this. And I'm going to pull out of here, get out of here, back on our page. Let's finish our answer. You guys are probably already way ahead of me, which is just fine. So we said 2, so our answer for number 4 is going to be the letter F and 2. Okay, now we've talked about our strategy today of making congruent shapes using pattern blocks. I'd like to go ahead and finish up working on our page today, and we'll be able to work on that right over here. Okay. This is kind of a backing up a little bit. We're going to go back and talk a little bit about line plots. This is something we haven't done in a while. It says use data for 5 and 6. So here's 5 and 6. Use the line plot at the right. Now, before I even get started, I want to get familiar with this line plot. Let's see. It has a label, movies seen last year. And I notice we go from 0 movies all the way up to 7 movies. And then we have the amount totaled up above. Now, just looking at looking at that, I bet you guys can tell me which movie, which amount of movies was the most popular, or which one happened most often, how many movies was the most popular. And I think I see a tie of how many movies were not seen. Okay, I saw 0 there. I see 2 saw 0 movies and 2 saw 6 movies. I also see that 3 people saw 1 movie and 4 people saw 4 movies. Okay, so we can tell right now the biggest amount of people saw 5 movies last year. Okay, let's look at our question here. It says each X on the line plot stands for 1 student. How many students saw more than 4 movies last year? Okay, this is where we need to think a little bit. Here's our question again. How many students saw more than 4? Now, to understand, saw more than 4. So more than 4 tells me bigger than 4. So let's look. Here's 4. They want to know how many people saw more than 4. So let's look at that. I want to see if I can find out. So how many people saw 5, 6, or 7 movies? I'm going to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I counted 12 students saw more than 4 movies. Okay, so for number 5, I'm going to go ahead and write my answer, 12 students. And I'm going to label it students. Okay, 12 students saw more than 4 movies last year. Okay, let's go on to number 6. What is the range for this set of data? What is the mode? Now, it has been a while since we've talked about range and we've talked about mode. Now, I'd like to talk about range first. Now, when I hear the word range, I think of things like ranging in size from small to large, ranging in noise levels from quiet to loud. So we're looking for the difference between the smallest amount and the largest amount. Now, when we do range, we're not talking about how many people voted. We're talking about the range of numbers of movies they saw. So let's look at these numbers down here. For the range, I have between no movies seen, 0, and 7 movies seen. I'd like to know what the difference between 0 movies seen and 7 movies seen. So if I think about that, the highest number of movies was 7 that someone had seen. The lowest amount was 0. Now, if I want to know the difference means subtraction. We're trying to figure out how many is in between that. 7 take away 0 gives me 7. So my range for this set is 7. I have a range of 7 different choices here, from 0 to 7. So I'm going to go ahead and write that down for number 6. We're going to finish up number 6. Now, number 6, the range from the smallest amount seen to the largest amount seen was 7. Okay, continuing on with number 6. They also want to know what the mode for this set of data is. Now, the mode, when I look at it, this is how I remember. Mode has M-O in it. Mode, most, which one has the most?